Thank you, Ron and Angelbeat. My name is Syed Sanur. I'm a solutions architect here at AWS. I'm also part of IoT technical field community. I'm here to talk about operation technology, OT cybersecurity today. So let's start by defining what is OT cybersecurity. OT cybersecurity is the practice of protecting your industrial environment against digital risks. It's not about just ensuring you're protecting the data, but also you make sure that you can run your operations in a safe and uninterrupted manner. It can also mean that it's about securing very foundation of our modern way of life, including critical infrastructure and industrial processes. So why this is really important? Let's talk about a scenario. Let's say that you are driving a self-driving car. What if someone hijacks and changes your destination address? What if someone can bring the entire factory operations to halt? Just think about the consequences. So it's not about just the IT is getting affected, but the implication can also create an havoc in the real world. That's the reason OT is not about just an option, but it's an imperative. In this slide, I'll talk about in the past decade, like as we see some of the serious trends in cyber physical attacks, right? So as I mentioned earlier, the attacks blurs the lines between the digital and physical worlds, causing a real havoc to our real life. So imagine the entire factory production system going on halt, or maybe the power systems coming to stop. Right, it could have a serious consequences in the real world. I would like to briefly touch on Colonial Pipeline attack that happened in May 7, 2021. A group identified themselves as dark side. They were able to infiltrate the company's network and were able to encrypt the data in their IT, and they demanded a ransomware. So what was some of the implications of it? The entire operations has to come to an halt. You know that Colonial Pipeline, they supply fuel to the half of the states in United States. As a result, there were fuel shortages that resulted in price spikes. So it also lead to a series of supply chain effects that also increased in panic buying. We also came to know that the company had to pay like about $4.4 million just to come out of it, but still the operations issues were still persisted. So what are some of the lessons that we learned from this attack? Right, it is right whenever we have this IT and OT convergence, it is crucial to prevent the spread of the threat. And whenever we have this kind of attack, a company should be able to easily recover from it. Now, as we saw that we had a presentation initially where VM showed how can we do that. And also there is a need to invest in cybersecurity. As we look ahead, right, there are several trends that is now shaping the future of OT cybersecurity. One of the notable trend is the integration of artificial intelligence and machine learning into the cybersecurity solutions. These technologies, they enhance threat detection, anomaly identification, and predictive analysis, enabling quicker responses to potential cyber threats. Around it, introduce about AI, right? These play a crucial role in making sure that the operations are run in an uninterrupted manner. And there are reports from various sources that suggest that uh, the the market cap for OT cybersecurity is estimated to be about $47 billion by the end of 2028. And as you see that whenever a company such as automotive can implement OT cybersecurity, uh, they can estimate about 19% revenue growth and about like 16% for the manufacturing industry. There are other market drivers for companies to adopt OT cybersecurity. We know that during digital revolution, we computerized most of the industrial operations, and during IoT, we are able to get the data from those digitized systems to make no anomaly detection or do command and control. As we enabled the internet, it also came along with the serious threats and intrusions that was possible. Cyber criminals are always looking new ways to bypass security controls and infiltrate networks. And then we also see that the traditional security measures no longer work for IoT solutions because of the more evolved or modern threats. So we have to know, we have to keep updated to the evolving threats. We also see that there is a convergence between IT and OT. As I mentioned earlier, anything that can happen in the digital world can affect the physical world. So this IT and OT convergence is not stoppable, but we have to make sure that the data flows seamlessly. And definitely there is a need for OT cybersecurity there. And we also see that whenever a company does any risk or vulnerability management, they often find that they are really missing a defensive layer or inadequate policies, and there is an opportunity over there. And we learned from the colonial pipeline attack that the nation has introduced additional OT measures to comply with cyber attacks. So in the next few slides, I'll talk about a couple of solutions that we can implement to resolve this. The first one is the ISA 95 traditional air grab. This is still an old methodology that's been still used in many industries. What they suggest is a clear network segmentation between the level 4 and level 3 and beyond. Like the ISA 95 standard, it also provides a model in which you can categorize your operations technology hierarchy as you see in the slide. Level 4 and level 5, it has the enterprise resource planning ERP and the product lifecycle management. So it says that the ERP and the PLM system should not have direct access to what is there in level 3 and beyond. Level 3 and beyond will have, right, for example, the sensors and actuators, the PLCs and the SCADA that are critical to run the operations. So in the traditional aircraft mechanism, what they suggest is that have a clear segmentation between level 4 so that if anything happens on level 5, level 4 or 5, they don't have a direct implication on the operations of the factory. But we also see that there is convergence in OT and IT, right? As the evolution of IoT and the Industry 4.0. So how do we achieve ISA 95 compliance at the same time? We need to provide the OT and IT convergence in a safe and secure manner. One of the approaches is to use cloud. As you know, AWS cloud is a scalable, secure infrastructure for enterprise applications, right? Supporting the OT and IT convergence. What you can do, you can take the level 4 and level 5 applications and you can run it on cloud. When you talk about PLCs, right, we can also extend the cloud to the edge. So whatever we're able to do in the cloud by means of edge computing, you can execute it on the factory floor or in an industry so that they can process the system in real time and can take action. For example, if anything happens to PLCs, if you have an AI algorithm sitting on the edge, it can detect and do the remediation accordingly. And we do have secure connectivity from the cloud to IoT devices so that it can ingest and process the data. So by using this technology, what we achieve here is providing a clear segmentation. For example, using AWS VPCs or private connectivity, we can include that clear segmentation between level 4 and level 3, so that if anything happens in level 4, they don't get propagated to level 3 and below. Right, and then here are now 10 golden rules for OT security from AWS. I don't have time to go through this all, but it starts with asset inventory, and it talk about patch management along with auditing and monitoring, and then we talk about encrypting your data and securing your network topology, and then establishing a business continuity plan and disaster recovery. So how do we achieve this robust production? Here is a roadmap for it. First, we identify the connected asset. When you say identify, we catalog like what are the devices available in your factory. We index them, and then we make sure that only the right people or the right service access those resources, right? And then we protect all these information through asset management. And then in the detect phase, what we do, whenever we find any issues, we have a mechanism to identify it. And then in the response phase, what we do, we either alert it to the people who are supporting, or maybe we run some artificial intelligence algorithm to mitigate it. And in the recovery phase, that is where we use no BCP and DR to make sure that your system is put back to the way it was no before the attack. So this is just a high level roadmap of how you can achieve this, and all this is possible using the AWS services. As you see here, in the identify phase, we can use AWS Service Catalog or AWS Systems Manager to catalog your resources. And then if you're running an IoT application, we use no IoT defend IoT device defender or IoT core to protect your devices, along with the IAM policies from AWS. And during the detect phase, we use services like Amazon Guard Duty, again Amazon Inspector or IoT Device Defender to detect, and then we can automate and respond or even investigate what's going on with these services, as you see in the screen. And then we recover using any third-party solutions like the one we saw earlier during the production, or from the natively from AWS in the recovery phase. Yeah, that's all I had today for the presentation. Thanks, Ron, for the opportunity again.